If you're a developer who wants to use AI to create applications, you have probably heard of vector embeddings, vector search, similarity search, but what exactly is a vector? So let me show you with a very easy to understand example. And so first we need a table, as always. We're gonna call these things, and things have a name. So this could be varchar, I don't know, 50, it's all right. And then we have our embedding, which is a vector. And a vector is a series of numbers, of floating point numbers. Now, when you create these embeddings or these vectors, you use a certain kind of AI called embedder. And they generate vectors with many numbers. And this is called also dimensions. So you can have, I don't know, maybe 300 or 700 or even 3,000 dimensions and so forth, right? But thinking about thousands of dimensions is a bit difficult. So in order to simplify this, we're going to use 2 dimensions only. And that's going to be very easy for us because we can create this plane with 2 dimensions where one indicates, for example, the speed of this thing, the thing that we are going to insert in this table. And the other one is going to be the size, right? So let's create this table and let's insert into things. Let's insert some values here, and I have them ready. So as you can see, we have 4 things, all right? And each one has a vector. So let's go through these very quickly. First, we have an alarm clock. Well, it's very small. It doesn't move. So we're going to assign that 0 and 0 in both dimensions. Now, a cow is not very fast, but it's very big. A bicycle, let's say it's not too big, not too fast. An eagle is very fast, but not too big, right? So let's insert those. Now, don't take these numbers too seriously. It's just keep in mind the idea and the relation between them, okay? So now we have 4 rows in these things table, right? So we have the name and we have a vector. Now, notice how I'm using MariaDB's vector from text function, right? That's because we want to use a string to define the vector. And because it has 2 dimensions, I have to specify 2 numbers per vector, right? And these are floating point numbers. Okay, so let me show you that data. Let's select the name and the embedding from things. And as you can see, well, we have data there, but this is like, it's bytes. So MariaDB is storing these as a series of bytes. Now, we use the vector from text function here. There is like a mirror one, which is vector to text. That's going to take the bytes and convert them back into a string. Now, notice also that this is an array in JSON format. So that's important as well. Okay. So let's say we want to calculate the distance between the origin of this plane to each object, right? So we can use a function called distance Euclidean. And it takes 2 vectors, right? Actually, this works. Thank you, Copilot. So first one is, let me close this meanwhile. The first one is our column here. And the other one is any vector that we want to define. So it could be, for example, origin, could be 0, 0, right? And then if we run this, we're going to see the distance, right? That's the distance from 0, 0 to each of the objects. Now we can order by the second column, which is this one. We could have used an alias here and then use it here, but let's keep it like that. And now they are ordered from closest to the farthest from the origin, right? Now maybe we are interested only in one, so we can say limit 1, okay? So we can do all this kind of stuff. And you know what, for my application, this distance, it actually doesn't have any meaning, right? There's no business meaning to it, so I can just say order by that thing. And now we have, well, the closest to 0, 0 is the alarm clock. Okay, so cool, but how can we use these in real life, right? What is it that we are doing here? Well, here we are calculating ourselves, or actually my brain calculated these vectors, right? What you would use in real life is you would use not this AI that you have there, but, or this more natural intelligence, I would say, but an artificial intelligence, right? So you're going to use a model, an embedder, and you're going to pass this string, for example, or whatever string it is, and it's going to create a representation, numerical representation, a series of numbers that encapsulate the semantic meaning of that text. Or it could be images, or it could be sound as well. Now, this is, like I said, these are very silly examples, just so that you get the basics. But let me show you something, because I already prepared a database here with a whole lot of, let me refresh, where's the things table? Okay, it's there. The products table, which has a whole lot of columns, like 1,000. It's not even too much, but okay, you have an idea. 1,000 products, and it has many columns. They are all here, right? So there's the primary key. We have an URL for that product, currency, final price, all kind of things. Somewhere there must be the product name. And I also added a embedding column. Let me click that one so it shows the definition. This is a vector, and it has these many dimensions, all right? So more than 1,000 dimensions. That's what we have here. And I used OpenAI's API to calculate these vectors on all the 1,000 products. And so you can see them here in this column embedding. And yeah, they are in byte format, right? But you know now how to show the actual string with the nice formatted numbers. But we're not interested in that. The data is there. That's what's important. We have calculated the vectors, and I calculated the vectors by sending something like the product name and the description. So these vectors, or this column, encapsulates numerically the semantic meaning of these products in terms of their name and in terms of their description. Here in this very basic example, it was only two things, right? So it was size and speed. Now this one has more than 1,000 dimensions, so it describes much more than that. And keep in mind that each dimension in these huge dense vectors, they don't map to real concepts that we understand. That's the nature of these AI models. Okay, so let's use that. Let's first select a random product. Okay, let's see how this goes. Select, I'm interested in the product name and the embedding. And I'm gonna insert that into a couple of variables. So maybe we can use N and E for embedding. From products, in order to select a random row, I can order by the function rand, and then limit 1. We only want one product. So let's see. Now, when I run this doesn't return any result set, but it stores the row here. Okay, it has to be only one in order for this to work. Now let's see what we got. So select the name of the product. Some sandals, all right? Crocs, sandals. Okay, well, that works. Let's use that. And likewise, we can get the value of the embedding for that product with the description. So remember, this contains now this name and the description of this product. So in a numerical way, so we can play with it and do similarity search. Okay, so let's say a user bought that thing. Okay, they bought this product, and we want to show similar products that they might be interested in. So how can we do that? Well, we can select product name from products. Now we're gonna order by vector distance. And before we use Euclidean, now we're gonna use cosine, which is a better function for this use case for text, similarity text in text. And this, again, it receives two vectors. So first, we're going to use the embedding that it's stored in the database. And now the value of the vector that corresponds to this product, right? And we can say, hey, give me just 4 of them. And maybe also something we could do here is where product name is not the name of the product that the user already bought, right? We want to repeat that one. Now let's execute that and let's see what we got. All right, it says, let me actually do this. Well, shoes, flip-flops. So they are related, right? So it's close. They are close to our products. And it's a good way to show related products. And that was super quick to get from the database. Okay. Now let's do something a bit more interesting also. So you don't have to use any vector that's stored. You can use a new one. So this curl command is actually calling the OpenAI API, the embeddings endpoint, and somewhere I have stored the OpenAI key, so I don't show it here. It's secret, it's protected. It's an environment variable. And then I'm saying, hey, use this embedder, text embedding 3 small, right? That's the embedding model that I use when I calculated the embeddings for all the almost 1,000 products in the database. But let's say we are interested in implementing search box, right? And where the user can type anything, and then we will like to show closer products to that, right? So let's say I'm interested in winter, winter is coming, winter gloves. And let's call that endpoint with those values. Right, HTTP 200 OK, so it worked. And you can see the response here as a JSON object, right? And somewhere there is the embedding, which you see is just numbers. It's an array in JSON format of numbers. So I'm gonna go ahead and copy all these things, all these numbers, the whole array. So it's 1,500 something numbers. Let's copy that. Let's make sure that I copy that. Let's get back to the code. And instead of comparing with these that we got from our database, I'm going to use it here. So vector from text, and I'm going to paste all that thing here. Okay, let's run that. So we should get something close to that. Let's see if that's true. Well, winter insulate, waterproof, insulated ski, snow globes. Yeah, it's related. Underwear, women's super soft long john. Yeah. Rain boots, waterproof. Yeah. So it's these are related, right? And that's one of the applications of similarity search. This is how you do it with MariaDB. Now, a couple of things that you should take into account is well, the first one is that I created. Let me show you that here. I created this products table and I added one embedding column there. Maybe that's not very good practice. Instead of that, just create a separate table and maybe even name the table with the name of the embedder that you are using. Because first of all, you cannot compare vectors that have different number of dimensions. That's one thing, and you wouldn't be able even to store them because this is fixed here. And the other thing is that even if they have the same number of dimensions, you cannot compare vectors produced by different embedders because they use a different model, right? And so each dimension will mean something different, and there's no point in comparing. It's just not gonna work. So separate that, put it somewhere else in another table, and name that table with the name, something that tells you, okay, this is for this embedder only, or maybe the name of the column or whatever you prefer. That's one thing. The other thing is that, well, here we had how many products? Just almost like 1,000 products. That's nothing really. But when you have millions of rows, then you will need to create an index. So create an index, and MariaDB has a very fast index on this column that's called a vector index. When you use an index, the search is going to be approximate. Just keep that in mind. And so you might want to do a hybrid similarity search where you actually search for textual coincidences and somewhat join the results. But that's it. So remember to use the vector distance, use the vector data type, use an embedding, an embedder that's high quality, that's very important, and then use a vector from text function. If you are sending from your programming language, you can send that directly as a sequence of bytes, then you won't need this function. But yeah, that was vector search. That's vectors, that's embeddings in short. I hope you liked the video. Thanks for watching, and I'll see you in the next one.